All right, so today we're gonna move to the next concept. This is called the continuity. So I want to start by the comparison. So we're gonna compare with calculus 1. So here in slide number 20, this is continuing from the last time. So in this slide, you can see that I have two boxes here. So on the left-hand side, you're gonna see that is the definition of continuous at the point x equal to a in one dimension. So in calculus 1, when you learn continuous, you say that a function f is continuous at the point x equal to a if three conditions are met. The first one is f at a exists. Second one is limit of f exists when x approach a. And the last one, if number 1 and number 2, they are equal to each other, you're gonna say that, hey, 1, 2, and 3, boom, the function f is continuous at the point x equal to a. This is what you learn in Cal 1 in one dimension. In two dimension, gonna be the same, everyone. We just need to extend to two dimensions. So to say that fxy, well, you can see now it's in two dimension. Fxy is continuous at the point xy equal to ab. So you can see the difference here is you're gonna have a function of two variables. The point that you have to focus gonna be just a point. It's gonna be an order pair xy, not just x now. Okay, and then this thing gonna be continuous if three conditions are met. So same thing. Condition number 1, you need f at a b exists. Well, this is the same thing as in calculus 1. Good. Well, you need to check that the function f is defined at the point a b. Second one, you need to compute limit of fxy where xy goes to ab. This thing, it must exist. So that is the condition number 2. Number 3, if number 1 and number 2, they are equal to each other. Well, that is condition number 3. So you need that. So you need these three conditions, 1, 2, and 3. If you have all of them, then you can conclude that the function f is continuous. You can see nothing harder than calculus 1. The same concept, but the hardest part going to be this part when you compute limit. Because as I told you last time, that when you compute limit, you could face 0 over 0. And that way you have to use conjugate or factoring, or you can show that the limit does not exist by picking the different lines. Or you can show that the limit is 0 by using the two-dimensional squeezing theorem. So you have few choices to compute limit. Okay, let's do a practice. So before that, let's talk about the property of continuous function first. Well, as in Cal 1, everyone know that the polynomials, trigonometric function, logarithmic function, exponential function, they are all continuous. Well, in two dimension is still good too. So if you see polynomial, trigonometric function, logarithm, exponential, these are standard functions that you can say that they are continuous. Fine. And if you see the sum of the continuous function, it's still continuous. The product of continuous function is still continuous. Well, continuous is a good property. So when you have two continuous functions, you sum it, you take a difference, you multiply it, or you do the quotient, they are fine. So the result that you get, they are, the continuous still over there. So you don't lose continuous property at all. This is a good one. This is a good property for continuous function. So keep in mind that you can use that if you want sometimes. Well, let's take a look at the example now. So for this class, my focus is I want you to know how to check that the function is continuous. So we're gonna mainly focus on how to check that the function is continuous. So let's start from example 9, everyone. So let's show that this given function is continuous at xy equal to 0, 0. So first of all, yeah, gonna be easy one because you have to check this condition number 1, condition number 2, and condition number 3. So condition number 1, you need to check that f00 exists. How do I know that I need to check this thing? So the question asks you that you want to check the continuous at the point 0, 0. So A is 0, B is 0. So which means you compute f00 and this thing is 0. Well, because you use the second function here, 0, right? Because when xy equal to 0, you use this thing. Do not plug in 0, 0 here because this is the case that xy is not equal to 0. Okay, number 2, well, we need to compute limit fxy where xy go to 0, 0. Well, everyone gonna see from last time that, hey, this is the function that we need to compute limit of 5xy squared over square root x squared plus y squared. It's gonna come back to the limit question. And you can see that if you plug in 0, 0 here, it's gonna be 0 over 0. Which means this is an indeterminate form again. So we need to do something with it. So for sure, I'm not going to do the factoring because there's no way I can factor in this thing. I told you this last time that x squared plus y squared, this is not a term that you can factor it. And also we are not going to do the conjugate because square root here, it's square root all the way up to the end here. So it is not like square root x squared plus square root y squared. In that case, maybe I'm going to use the conjugate, but this case, no way. So I'm not going to use conjugate. So if you're trying to pick different lines, it would work sometimes, right? But this time, I don't see the way that you can do it. Well, you can spend like 1 or 2 minutes to think about it. If you pick the line y equal to 0, it's going to be, oh, actually 0. If you put the line x equal to 0, it's actually 0. If you put line y equal to x, it's going to be 5x cubed over x squared plus x squared, and then square root, and then over here, and then, you know, the top going to be heavier again, and then at the end, you're going to get 0 again. Well, if you spend like 1 or 2 minutes, well, it is worth a try. And then you're going to see that no matter line you pick, it's going to get 0 always. So if you pick like 3 or 4 lines already and you feel like, oh, it's all 0, I feel like limit is actually 0. Okay, then we're going to go to squeezing theorem. Okay, so I'm going to set aside here. Well, we're going to trying to do the squeezing theorem into dimension. Okay, let's do it. So 5xy squared over square root x squared plus y squared. Well, this is from last class. If you forget it, well, it's time to do a review. So we're gonna split it here and here. I need 2 functions, right? Like last time, I need this part to be my f, and I need this part to be my g. What I want is, I want that my f, well, no matter what, what I pick here, I need absolute fxy to be less than m. That is number 1. Number 2, well, whatever you have left for g, if you take limit, it must be 0. Well, I'm gonna do the trick that we did last time. So we're gonna keep square root x squared plus y squared to the f part, because this is going to be a good way that we can bound a function. So this time I'm gonna do, okay, x square root x squared plus y squared. You go with f. Well, what should I do for to pick the f1 over there? So of course I want at the end I get 1 here. So it's gonna be a good one that I can bound it. So to get 1 at the end, maybe you're gonna do square root x squared plus y squared here over square root x squared plus y squared. Okay, this is 1. This is actually 1 because they are the same thing, right? And if you think this should be something bigger than, okay, I need more space. I need more space, sorry. Here, I'm gonna go down over there. So this should be something like, well, on the bottom one, I have x squared, y squared. The top one, maybe I'm gonna do square root x squared. Well, this is a trick that you can see that here, square root x squared plus y squared. Again, this is always bigger than or equal to just x squared, because this time you add y squared, boom, and then once you add y squared, this term must be bigger than that term. And this is why we say less than or equal to here. And well, when you have x squared over there, so it's gonna come back to x here. Fine, then I'm gonna keep x here. Everything else, 5y squared, you go to g. Does it make sense? This is a trick that everyone see it few times already, so should absorb this thing and trying to do it by yourself later. And then here we're gonna say limit gxy, this is limit of 5y squared, well, for sure 0. Well, from these two things, so we're gonna say, well, I'm not good at splitting the space now. Then by two-dimensional squeezing theorem, this limit is actually 0. 5xy squared over square root x squared plus y squared. This is indeed 0. Okay. Sounds good. So which means here this is actually 0. For well, yeah, so number 1 and number 2, they are the same thing. So which means step number 3, f0, 0, this is actually equal to limit fxy, where xy go to 0, 0. So 1 check, 2 check, 3 check. So 3 conditions are met. So you conclude that f is continuous at the point xy equal to 0, 0. Make sense? Well, again, you can see that the hardest part come back to the part that you need to compute limits. Yeah, but the continuity is not that hard. You just extend the idea to check number 1, 2, and 3. 3 condition met, you're done. Okay, so let's do one more example, everyone. Hopefully this example is good. Any question on this example? Well, some of you are gonna ask me, maybe, well, some of you have something in your head, and Ajahn, would it be possible if I do square root y square here? Again, yes. If you do square root y square here, keep y here and keep y here. So then this is gonna be 5xy. Fine. Same answer. So continuity, yes. This squeezing theorem give you more room to, to get different solutions. So you don't have to get the same solution with your friend or me. Well, you can pick different ways. You can pick this thing different way. Yeah, fine. Okay, let's do example 10. Discuss the continuity of the function fxy equal to this thing. So again, they want you to check the continuity of this function. Okay, first of all, you can see that they didn't mention that they want to check the continuous at the point here, but they want to check the continuity of this function. You can see that at any point that is not 0, 0, you're going to have no problem about continuity. Why is that? Look at that first. Well, I'm going to say here, at xy is not equal to 0, 0, we have no problem with the continuity of the function. Why is that? Because when xy is not equal to 0, 0, you only use this function all the time. This thing is not going to be your problem. Well, at xy equal to 0, 0, any point you use this function. And this function, this is a quotient between polynomials. You see, y to the 10 is polynomial. 2x squared is polynomial. Y to the 10 is polynomial. x squared is polynomial. When you add polynomial together, it's still you add y to the 10 and x squared. This is the sum of continuous function. So continuous, add them up with the continuous. It's still continuous on the denominator. On the top one, you take the difference. It is this term on the numerator still continuous, and you do the quotient. It's still continuous. How do you know? Well, you sum it. It's still continuous. You do the product. You do the quotient. It's still continuous. And polynomial, trigonometric, log, exponent, anything, the basic function, they are all continuous. So which means you're gonna have no problem at all on any point except 0, 0. Because you know that this is a quotient of sum of polynomials. Make sense? The only point that you're gonna have a problem is 0, 0. Why is that? Because you use different functions. Well, near 0, you use this one. Exactly at 0, you use this one. So basically, you need to check the continuity at 0, 0. Well, this is good. All right, then at x, y equal to 0, 0. Okay, let's try to do at this point. Well, we have, again, 3 steps, 3 conditions. Number 1, you need f0, 0 is actually 0. Good. Number 2, you need limit of y to the 10 minus 2x squared over y to the 10 plus x squared. Xy equal to go to 0, 0. Well, don't go to squeezing theorem yet. So again, the best way to compute limit, trying to plug in first, plug in 0, plug in 0, plug in 0, plug in 0. Wow, it's gonna be 0 over 0. Okay. Conjugate is not my thing for sure. I don't see square root or I don't see anything that you can do a conjugate. Factoring could be, but super hard because you have y and x here. That's no common term. So how do you factor it? No common term here. A little bit hard to factor. So we're gonna avoid factoring. So picking a line. Anyone have any idea that you're gonna pick the line and you get different limits? Well, tell me in the chat if anyone have any idea. Should we pick 2 different lines and get different limits? I'm waiting for the answer. So anyone want to pick the line? So let's give me the line that you want to pick. Okay. So the first student, Igor, right? Y equal to x squared. Let's follow him. So he's gonna pick limit x, y go to 0, 0, where y equal to x squared. Let's try it. And then on y equal to x squared. And then you're gonna get here y to the 10 minus 2x squared. Okay, let me copy the question first. If you get y equal to x squared, okay, let's see what happened here. It's gonna be x to the 20, right? And then minus 2x squared, and then at the bottom you get you take y equal to x squared, so that is x to the 20 again plus x squared. Okay, and then now you can pull out x squared. Good. X to the 18 minus 2. And then, am I right? And then x squared, x to the 18 plus 1. Okay. If you pick y equal to x squared, and then that cancel out, you plug in 0. What do you get here? -2 over -1. No, over 1, -2. Agree with me? So you get -2. Well, can you find another line that give different limits? So, well, first of all, any questions on what he suggests here? So actually, this is a good one. Huh? Ego, you are a good student. So this is a good one. So y equal to x squared is a good one because when you plug in and you can see that you can factor it out. And yeah, perfect. This is -2. I like it. I like it. Well, yeah, some of you say x equal to 0, y equal to 0. Yeah, that would be another one that you should do, because pick the easy one. So if you pick x equal to 0 or y equal to 0, you can see that if you pick x equal to 0 here, it's going to cancel out. And then you get 1. You know, good way. So x, y equal to 0, 0. And then now this time you do on, let's say x equal to 0. Let's take the simple one. Y equal to 10. Okay. Fine. So now you get limit y to the 10 over y to the 10. You can see I never abbreviate my notation, because what I hate a lot is, well, I'll tell you in a minute. This is one. What I hate a lot is usually students gonna just do it quickly and you delete this thing and then you do this. Well, I hate to do that. Well, I like to keep my notation all the way, because so it does not make sense to me when you delete the limit notation over there, because we are computing the limit. This is not the polynomials. Well, in your scratch paper it's okay, but when you write it formally, it's not okay that you delete the limit notation. Well, I used to fight with American students a lot when I teach class over there. Like when I was TA in America, yeah, I fought with students a lot about the limit sign here. But that's the funny thing. So number 1 here, this is -2 here. So you have different limits now. Yeah, so the limit does not exist. From here, the limit does not exist because we found 2 lines, actually 2 curves with different limits. So which means number 2 limit does not exist, which means no way that this function is going to be continuous at the point x, y equal to 0, 0. Because the condition number 1 passed, condition number 2 failed. So you can conclude immediately that f is not continuous at 0, 0. Make sense? Well, it is continuous on any point except 0, 0. This is this question. Well, do you guys have any questions for me for this question? No? Good. So far so good, nah, everyone? Okay. Well, the last example, I think, yeah, last example for this handout. So here we're gonna need to find k, the value of k, such that this function is continuous. Well, for sure, we're gonna on r square. Wow. Again, you can see that it's continuous at any point except 0, 0 for sure. Because on the top one, this is the trigonometric function and polynomial. You multiply them together, this is the product of continuous function. It's still continuous. On the bottom one, this is a sum of the continuous function. It's still continuous. So you do the ratio between them. Yeah, fine. They are continuous at any point except 0, 0. Well, all you need to say that the function is continuous on the whole domain, the entire r square, you need that the function must be continuous at 0, 0. Well, so that means number 1, you need f 0, 0. Number 2, you need limit xy equal to 0, 0. And you need to specify, you need to force that number 1 and number 2, they are equal to each other. If you can force these 3 conditions, then the function is also continuous at 0, 0, and that is going to be your answer. So you can solve for k. Okay. Number 1, this is k. Wow, good one, good one. This is k. This is easy. So number 2, you need to compute limit. Okay, come back to limit problem again. Well, what are we going to do this time? Then squeezing theorem, right? Well, I don't know about you, but in calculus 1, when you see trigonometric function, you always use sine x between -1 and 1. If you remember in cal 1, and then you do, hey, Ajahn, do that, and then squeezing theorem. Well, when you see trigonometric function, it is suggests that squeezing theorem could be a good tool to solve this problem. Does it make sense? Well, if you don't trust me, you can try to plug in 0, 0. It's gonna be 0 over 0. And then if you trying to factoring, conjugate, or picking a line, no good, because it will not work. Because at the end you're gonna, yeah, you can see no way to factor and conjugate for sure. If you pick the line, it's gonna be hard here because you have sine x, y. If you pick y equal to 0, x equal to 0, or y equal to x, well, at the end you're gonna have the problem with x squared here. Because, well, I mean, at the end you're gonna get 0 on the top, and the bottom gonna be okay can be some number, some good number, but at the end the limit's gonna keep getting 0. If you're picking different line, x equal to 0, y equal to 0, x equal to y, and so on, you're gonna keep getting 0, 0, 0, 0, 0 again. You can try, and at the end maybe we're gonna do the squeezing theorem then. Okay, we're gonna again, for squeezing theorem, I love to save my space here to do squeezing theorem. Well, I'm gonna do x squared times sine xy here over x squared plus y squared. So we're gonna split it into two functions again, everyone. So I need my f, I need my g. Well, what is going to be my f and my g here? So I'm gonna do like last time. Well, this is, I think, the third example or the fourth example already. So I'm gonna go faster, okay? So I'm gonna keep x squared plus y squared here. Okay, then fxy gonna be, okay, take absolute, shoop, shoop, x squared plus y squared. How can I bound it? So at the end, I need 1 is good number. I love 1 here. So this should be x squared plus y squared over x squared plus y squared. Wow, 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 wow. So I have x squared here. Less than or equal. Good. For sure, x squared, you're gonna be less than x squared plus y squared for sure, because y squared is always non-negative. And then, yeah, that's mean keep that x squared here and sine xy to be my g. Perfect. This is so simple and easy. So my g gonna be limit of my function g gonna be something that is easy to compute, because it's gonna be limit sine xy, where xy goes to 0, 0, and that's gonna be sine 0, and sine 0 is 0. Okay, when you compute trigonometric function, make sure everyone it's a radian. The unit is a radian. Do not compute sine and then you use degree. From math class, this is not a high school class. Well, from now on, the upper level class from undergraduates, graduates, and so on, everyone gonna use radian. No one gonna use degree. So when I say sine pi over 3, well, when I say sine 60 degree, I'm not going to say sine 60, I'm gonna say sine pi over 3. Everyone need to be comfortable to use this number, pi over 3. Does it make sense? So we are not going to use sine 60 degree. Well, we're gonna learn integration soon. And when you learn integration after Songkran, I'm gonna use radian always. No degree. Okay, it is not common in the real world that people use degree. Well, when you were a kid, yes, it's easy to explain to kids, but in the world of science and engineering, people use radian. So you have to be comfortable with radian. So 0 is fine. So 0 is 0 degree and 0 radian are the same. But well, later on, I mean, when we get to the integration content, so keep in mind, I'm gonna use radian all the time. And then this gonna be two condition met, or condition are good now. So that means by squeezing theorem, limit of this thing gonna be 0. All right, and that is very simple, right? Which means you can now get this thing equal to 0, and then, okay, it's gonna be false that k equal to 0. Good, I get the answer. Done. So k equal to 0 is the one you are looking for, because this is gonna be the one that give you a continuous function on the entire R square. Well, this is the continuous function. You can see that what we learned today, the content is so much similar to what we learned last week, right? We just extend the idea of the continuous thing. Okay. Well, you have practice problem to do. So again, this type of question is just the computing the limit by plugging in. This type of question, I ask you to evaluate the limits. Yeah. Well, see the sign here. The conjugate is coming. Factoring is coming. Maybe this is the show that it does not exist. This is show that the function is continuous. Okay, maybe you need to compute this limit. Well, determine if the function is continuous. So maybe it is not continuous. Evaluate this thing. So, well, you see sin xy here. Maybe squeezing theorem is coming up here. And then the last one, phi k, such that the function is continuous at this one. Well, maybe you need to factor something. All right, so the solution for this thing gonna be posted on YouTube. So I'm gonna use a clip from last year because I recorded from last year to be the solution for example 12 to example 17. We don't have time to cover all of this thing in class. So the solution gonna be on the YouTube channel. If you do it, you wanna check the answer, go to my YouTube channel. So you're gonna see solutions step by step on each question. Does it make sense? Well, don't rely much on the solution. You know, if you learn from watching the solution immediately, if you jump to look at the solution immediately, you're not going to learn anything. So the best way to learn is try to do it by yourself first. If you get stuck, look at the solution. Okay. Well, I have question now. Oh, so some of you have question sent to my private chat that can you explain this thing? Yeah. Number one, f00 is k. Number two, limit of this thing is 0. In order to get the continuous function, you need to force that number one and number two, they are equal to each other, right? So you can get number 3 here. This is why I force that k equal to 0. So I force k equal to 0, so the function is continuous. Sounds good? Okay, so that is the end of the first handout in this chapter, limit and continuity. Hope you feel like this is not too hard for you. Okay, so the limit and continuity for sure are going to be on the final exam. I am not sure I'm going to put 1 question or 2 questions on this, but they're going to be at least 1 question on it. So you probably need to practice from now on, and then you're going to see it again on the final exam. I think I usually put 1 or 2 questions about this content for this handout on the final exam. So it's supposed to be the easy question. Yeah, because the content for this part is very easy. Okay, so I'm gonna keep you with me 10 minutes more because we're gonna talk about derivative, and then we're gonna come back to look at derivative again on Wednesday. Okay, so in the meantime, everyone who are here, type your name in the chat so I know you are here. So checking in, everyone. We're gonna talk about partial derivative a little bit, and then we're gonna let you go. So type your name in the chat, everyone. Okay, so I know you are here. Good, thank you. I think the name is unique, right? So anyone have the same name with? Well, if you know that you have the same name with other students, just type your surname too. So I know which one is you. Okay. Here we go. So we're gonna look at derivative. So we're gonna talk about derivative again on Wednesday, everyone. But today we're gonna look at how we differentiate it in 2 dimensions. So in 1 dimension, you know that if you have a function, you can differentiate it by using the formula. So the formula that you do in calculus 1, keep it going because you can use it in Cal 2 too. So, well, this is, sorry, 1 second. This is a new handout. I already posted on Blackboard. You can download it. But if you need more time to download, let's listen first. This is only 5 to 10 minutes. And then, well, you can download later. Okay. just listen to the idea first. So the idea of derivative that we're gonna learn on Wednesday is that we're gonna start from fx equal, well, this is in one dimension, minus 2x squared minus x plus 2, and then you can take derivative. Well, you know the formula already from Cal 1 that, hey, everyone know how to differentiate this thing. Simple, very simple. And then keep in mind that all formula from Cal 1, you can use it for function of two variable. The difference is that you need to keep one variable constant. Otherwise, you cannot differentiate. Because into the, well, differentiation in two dimensions, we're gonna say that we have two ways to do it. Differentiate with respect to x or differentiate with respect to y. We're gonna define it properly on Wednesday. So basically, this is it. This is what we're gonna do in two dimension, everyone. So we're gonna say that we have two ways to differentiate. So you can differentiate, well, diff with respect to WRT it with respect to x. This means you're gonna differentiate by you are looking at x to be your variable, y gonna be constant. And another way you can do differentiate with respect to y. This one you're gonna keep y to be your variable and x gonna be your constant. So this means y is constant. This means x is constant. Well, the formal way to define derivative here, you can define formal way by using the definition, because in Cal 1 you define by limit fx plus h, right? And then minus fx over h, where h go to 0. This is how you define derivative in calculus. And well, if you are good at calculus, you're gonna remember this thing. This is actually the formal definition of derivative in Cal 1. We're gonna talk about formal definition of derivative in two dimensions on Wednesday. So we can define the same thing as we did in Cal 1, just extend it into dimension. But today, because we don't only have 5 minutes together here, we're gonna look at example. So I'm gonna show you how to do it in practice first, and then we're gonna come back and learn the theory on Wednesday. Okay, this is supposed to be easy. So take a look, take a deep breath. Okay, everyone, take a look at how we do it. So we're gonna skip the theory first. Let's do example 18. Okay, this is your first example on derivative. Let's see how to do it. So you have fxy to be this function x to the fourth power plus 3xy squared. 3x squared y minus y cosine x plus sine y minus square root 15. So this is critical. If you understand this example, easy one for you. So let's see if you get confused with this thing. So first of all, I'm gonna say differentiate with respect to y, to x first. Well, when they say find partial derivative, it means they want you to find differentiate with respect to x, one thing, and differentiate with respect to y, another thing. Okay, so let's start by with respect to x first. So my notation is gonna be f xy. When you differentiate with respect to x, people gonna do the subscript here. If we write f subscript x, this means you differentiate f with respect to x, okay? Which means you're gonna keep y as your constant, you differentiate x. So here you're gonna differentiate x, you get 4x cubed, and then plus, well, 3x squared y gonna be, let's see that one. Y gonna be your constant. Number 3 gonna be your constant. You only have x squared. That is your variable. So you're gonna keep 3y because 3y is constant. And x squared, the one that I highlight in yellow, this is actually your variable. So you differentiate x squared, so you get 2x. Make sense? Do not touch constant. And constant here is 3y. Here, next one, minus y is constant. Leave it there. Leave it there. This is constant y. Do not touch it. Differentiate cosine x. Yes, you have to. Differentiate cosine, you get negative sine. And then next one, sine y here. What the fuck, Ajahn? Sine y is constant. So yeah, this is constant. So actually sine y when it's square root 15, they are all constant. So 0. Sounds good. And then here you're gonna get 4x cubed plus 6xy plus y sine x. This is the partial derivative, the derivative with respect to x. Okay, that's the first one. So let's do differentiate with respect to y. Okay, so here you're gonna do f subscript y. Okay, all right. So okay, so questions in the chat first. Well, when you ask question, please ask in public, okay? Because you do not need to do the private chat because you are public. So because I know a lot of you have the same question. So again, ask question, you help people. So some of you have a question already that why do I differentiate sine y and then I get 0? Well, because y is constant. Y is constant when you differentiate with respect to x. Keep in mind that y is constant. Everyone, y is constant. This is just number. This is number, okay? And then you differentiate number, you get 0. Cup. Sounds good. Well, if you still like you are not confident, let's do another example. Everyone, let's do it together here. If you want to differentiate with respect to x, differentiate with respect to y, x is constant. So when you see x, that is a constant, okay? You differentiate x, well, let's look at here, the term that I circle here. X to the 4th power, this is constant. This is not a variable, this is constant because x is a number now. So 0. Okay, now the next one, 3xy squared, x is a constant. So 3x squared, they are all constant. The only term that you need to differentiate is y. So you differentiate 3x squared y, what would you get? 3x squared. Right? If you differentiate 5y with respect to y, you get 5. You differentiate negative 7y, you get negative 7. You differentiate any constant times y, you get that constant, right? So that constant is 3x squared. And then the next one, y, look at this one, negative y cosine x is constant. Well, you just need to differentiate that and you get negative cosine x. And this thing called sine y, differentiate sine y. Now, this is not a constant because y is a variable. So differentiate sine, you get cosine. And then differentiate negative 15, you get 0. Well, simplify. So 3x squared minus cosine x plus cosine y. This is partial derivative differentiation with respect to y. Give the thumbs up if you understand how to do the partial derivative. Well, I'm gonna see how many people understand it because this is what we're gonna learn again on Wednesday. Good, 5 people. The thumb up, 6, 7, 8, 9. Well, if you feel like this is easy, good for you. This is what you're gonna learn on Wednesday. You already understand it. Good. Thank you, everyone who do the thumbs up. Well, we're gonna talk more about partial derivative here on Wednesday. Okay, if you feel like this is weird or odd for you, try again on Wednesday. We're gonna look at more and more harder example. So you're gonna see that this time you have to use chain rule, you have to do something product rule more, you know, but this is a simple function. But the idea of the differentiation is if you want to do differentiate with respect to x, keep y constant. If you want to do differentiate with respect to y, keep x constant. And you see that the next question they're going to ask you here, f subscript x. So it means you need to differentiate with respect to x of this function. And then you plug in 2 and 1. You need to, wow, this is another notation we're going to talk on Wednesday. This is differentiate with respect to y. and then you plug in 1, 1. You can see the function that I give you gonna be a little bit harder each example. We're gonna learn how to do that, how to do that, how to do that. Just keep climbing up to harder and harder and harder and harder to see, you know, give you a challenge. But this one is the simple one. Okay, hopefully you feel good about this thing. Well, if you feel like this is so hard, Ajahn, well, don't be scared. This is your first time to learn differentiation in 2-dimension. You still need more time to absorb the content. It's fine if the first day is, you know, if your first day is a nightmare, fine. Well, you're gonna be better each day you learn. Okay. Any questions? Any question on this thing? If not, well, it's 11:50 already. Yeah, we should stop the class, right? 11:50 already. All right, so thank you everyone for attending. So it's gonna be 15-minute class all the time, so I don't want to push you too much. Well, let's see you again on Wednesday, okay, at 10. Thank you everyone.